Hi, welcome back to my channel. The popular 12-fact app methodology is the best practice to build modern cloud-native applications. In this video, I will discuss how to apply the 12-fact app methodology on the public cloud with the selected cloud-native services to make scalability and resilient applications. There are 5 key features of the 12-fact app methodology to build modern cloud applications. I highlighted the keyword of each feature, so I'm not going to read them one by one. These 5 key features are associated with CI/CD, continuous integration and continuous deployment, microservices, and containerization. I will use cloud-native services from AWS and GCP to describe each factor. The first one, Codebase. You should track your codes in a version control system such as Git or Mercurial. A copy of the version tracking database is known as a code repository, or just short for code rep, or just rep. The rep provides a place from which to do the continuous integration and continuous deployment. You can set up a private or self-hosted rep. Public cloud providers also offer version control services that you can use to privately store and manage assets such as documents, source code, and binary files in the cloud. GCP uses cloud source repositories to collaborate and manage your code in a fully featured, scalable, private Git repository. AWS uses a Git-based service code commit to eliminate the need for you to manage your own source control system or worry about scaling its infrastructure. We will talk more on the CI/CD in number 5, build, release, and run. The second one is dependencies. You should automate explicitly declare dependencies in a CI/CD process and isolate the application with its dependencies by packaging them into a container. Many programming languages offer a way to explicitly declare dependencies, such as Node.js uses npm, Python uses pip, Java uses Maven, C# uses NuGet, Ruby uses Bundler, Go uses go-get packages. All public cloud providers offer the container registry, such as GCP's Container Registry and AWS Elastic Container Registry, to store, manage, and deploy Docker container images. You can integrate the container registry with the existing CI/CD to simplify your development to production workflow. The third one is config. Storing config as constants in the code is a violation of a 12-factor. Config varies substantially across deploys, but code does not. So the best practice should store externally for each environment and strict separation of config from code. If you're still doing this by creating the configurations files, then you should check out the better approach in the public cloud by storing configuration in the environment variables. For example, leveraging the Lambda environment variables to store the secrets securely and adjust your function's behavior without updating the code. Or create a Kubernetes config maps to bind environment variables, port numbers, configuration files, command line arguments, and other configuration artifacts to your pods, containers, and system components at runtime. Number 4, backend services. Backend service is any service the app consumes over the network as part of its normal operation, such as database, messaging, queuing system, file systems, and caching systems. These services should be accessed as a service and externalized in the configuration we just went through. The published cloud provides offer the cloud-native fully managed services for the backend services. For example, cloud storage with AWS or GCP cloud storage for file systems, databases on AWS or GCP cloud databases for all kinds of databases, such as relational, NoSQL, data warehouse, in-memory cache, graph, and ledger. For the message queuing, AWS provides SQS, Kinesis, and GCP provides PubSub. Number 5. Build, release, run. The 12-factor app uses strict separation between the build, release, and the run stages. So you should have a CI/CD process for development and deployment. The deployment tools typically offer release management tools. Every release should always have a unique release ID that's a result of combining an environment's configuration with a build. The release management tools should have the ability to roll back and track the production deployment history. Let's take a look at two sample diagrams show the detailed view of the CI/CD pipeline steps from GCP and AWS. In the GCP CI/CD pipeline, you can see that the deployments to the test and production environments are separated into two different cloud build pipelines, a test and a production pipeline. In the test pipeline, the developer first commits code changes to the cloud source repositories. Then the code changes trigger a test build in the cloud build. Cloud build builds the self-execution jar file and deployed it to the test jar bucket on the cloud storage. Then Cloud Build deploys the test files to the test file buckets on the cloud storage. The Cloud Build sets the variable in the Cloud Composer to reference the newly deployed jar file. Then Cloud Build tests the data processing workflow DAG and deploys it to the Cloud Composer bucket on cloud storage. The workflow DAG file is deployed to the Cloud Composer. Then Cloud Build triggers the newly deployed data processing workflow to run. Now let's move to the production pipeline. A developer manually runs the production deployment pipeline in the Cloud Build. Cloud Build copies the latest self-executing jar file from the test jar bucket to the production jar bucket on the cloud storage. Cloud Build tests the production data processing workflow DAG and deploys it to the Cloud Composer bucket and the cloud storage. Then the production workflow DAG file is deployed to the Cloud Composer. Now let's take a look at the AWS CI/CD pipeline. You create a release pipeline in the AWS code pipeline. First, connect a source repository such as AWS Code Commit or AWS S3 or GitHub to your pipeline. Then automate code deployments by connecting your pipeline to the AWS code deploy to deploy the code changes committed to your code repository to AWS EC2 instance. In this pipeline, you can also plug in a build service such as Jenkins when you complete the four-stage pipeline. Number 6. Process. 12-factor processes are stainless and share nothing with each other. Any data that needs to persist must be stored in a stateful backend service, typically a database. If the application has sticky sessions on-prem, Then you need to change the way to handle the persistent data in the cloud. Both GCP and AWS offers fully managed in-memory data store service for Redis and Mac cached with scalable, secure, and highly available infrastructure. So you can use AWS Elastic Cache or the GCP memory store as a backend service to cache the state for your applications and share the common data between the processes. Even more, you can leverage AWS step functions to coordinate the components of distributed applications and microservices using the virtual workflows to execute the processes in order and as expected. Number 7, port binding. The 12-factor app is completely self-contained and does not rely on runtime injection of the web server into the execution environment to create a web-facing service. So you need not hard-code port numbers in your code. Instead, you should follow what we mentioned in the config to store port in the environment. If you're using AWS Elastic Kubernetes Service EKS or GCP Kubernetes Engine GKE to run the containerized applications, then the Kubernetes provides the service discovery by the mapping the service ports to the containers. Number 8, concurrency. You should adopt the microservice architectural approach to software development. Microservices architectures allow a large application to be decomposed into small independent services that communicate over well-defined APIs. It makes the applications easier to scale and faster to develop, enabling the innovation and acceleration time to market for new features. The following cloud-native service offer the auto-scaling: AWS Lambda or GCP Cloud Functions, AWS Auto-Scaling or GCP Auto-Scaling Groups, AWS EKS or GCP GKE. Number 9, disposability. The 12-factor app's processes are disposable, meaning they can be started or stopped at a moment's notice. So you should make sure the startup time is minimal, such as how long to perform the startup scripts, load the images, initiate the packages, and complete the tasks during the startup time. You should follow the number 4 process and number 6 backend service for decoupling the functionality. Manage the environmental variables with the number 3 config fact so you can use them during the runtime. Processes shut down gratefully when they receive a single-term signal from the process manager, for example, from the stop task in the AWS ECS, terminating with the grace in the Kubernetes. Number 10, Dev Prod Parity. The 12-factor app is designed for continuous deployment by keeping the gap between development and production small. You should follow the Codebase and the build release run to manage CI/CD. You can also use AWS CloudFormation or GCP Deployment Manager to provision and model your cloud resources from development to the production environments. Number 11, logs. A 12-factor app never concerns itself with routing or storage of its output stream. It should not attempt to write to or manage log files. Public cloud providers follow this fact by offering operations services to help you to track the performance of an application. Examples include AWS CloudWatch and GCP Cloud Logging. The last one is admin processes. One of admin processes should also follow the same codebase, dependency isolation, and configure as any process in the same release. Admin or management tasks can be triggered by AWS CloudWatch events, the cloud job in the Kubernetes in either AWS EKS or the GCP GKE, complicated jobs in the AWS batch or the AWS ECS scheduled tasks. Here is the conclusion. The best practices from the 12-fact app methodology provide the approach to build cloud-native applications. The public cloud providers offer managed services to ease the design and development cycles. Besides the 12-fact app methodology for the cloud-native application development, we also need to concern the security on the published cloud. I will cover this topic in the future video. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.